Hey guys, so in this video we are gonna solve this copy list with random pointer question. So we are given a linked list which is in this order: 3, 4, and 5. Let's say this is a linked list. Basically, instead of having two keys, it also has a random as a attribute. So one can randomly point to, let's say, 3, right? One can randomly point to 3, 3 can randomly point to null, 2 can randomly point to 4, and 4 can randomly point to 1. And our task is to get a deep copy of this linked list so that we have another linked list, but none of the node in this another linked list has an access to the original linked list that is given to us. And how are we going to do this, right? So from what we talked so far, this sounds to me like a deep copy of a original linked list, right? And now are we going to approach about making a deep copy? Another linked list that has like this. This is a deep copy, copy. Even if we just do a deep copy, it is not enough. We need to do another copy of the random pointer as well. So 1 has to point to 3, 3 has to point to null, 2 has to point to this, and this is what we need as a solution. Just doing a deep copy of this linked list is not enough. We have to do a deep copy of a pointing next references as well as the random references as well. And so this is the main like logic how you gonna solve this question. So you are given a linked list like this, and if you create a deep copy of each node, then think about this. If you create a deep copy of each node, we create a deep copy of every single node given in our linked list, original linked list. Then this way we can at least we have all the node that we need to reference now. Either that's a normal node, or that's a next node, or that's a random node. So if we make a deep copy of every single node, we have a valid solution. We have like a door for valid solution. Every single original node has the deep copy reference as a next node. This is what I'm gonna do first step. And the second step, what I'm gonna do is, like, one had random access to 3, so this 1 dash should also have random access to 3 dash, and 3 has access to null, so this 3 dash will also have access to null. And now this 2 has access to 4, this prime has access to 4 prime, and then 4 prime has access to 1 prime. So this is what we need to do. We need to create a deep copy of every single node, and then we also need to have a random access of this newly created node to another newly created. Create a deep copy of every single node first and chain it in the original list, and then assign the random pointer of this newly created node to this newly created one access to the another newly created node. So newly created node to original random's new node, newly created node. And so once we have this access, what we're gonna do, we'll break this. So this means we'll have this 2, 3, and 4, and then we'll have 1 dash, 2 dash, 2 prime, 3 prime, and 4 prime. I'm saying prime for this one, I'll just reference it as prime. So this is what we need to do. And for finally break the original chain into 2 chains, original versus and a newly created nodes list. Okay, so this is the plan of attack. And so now let's write a formula for deeply create every single node. So this is what I'm going to do. Let current node equals to, we are given a head, so this is what our head will be. Let's start. So while current node exists, what I need to do, create a new node. This is deep copy. So basically new node equals to underscore node, and let me make sure this is correct. Underscore node value random next, and yeah, this is right. And then so I'll just pass current node dot val, right? And we created this, so we are here right now. We want to create this new node. So one dot next was two earlier, one dot next was two, one dot next was two, but this time the newly created node should point to the two. So this is what I'm gonna say. This newly created node, new node dot next has to be current node dot next, right? And so now this is established. Now I need to say current node next has to be this, and then node dot next has to be new node. Okay, now this is what I'm going to say. And so I successfully established a connection that one dot next, basically one dot next was originally two. Now our new created node points to two, and then our current node dot next will be this. So basically we introduced this part. Now what I need to say, our current node has to be updated to this part. This. So current node, now current node dot next becomes the new node. Current node dot next equals to this becomes the current node dot next becomes the new node. Is this, um, and then we do one more. Current node equals to current node, but we want our current node next to be uh, 2. So how are we going to say that? How are we going to say our current node? Our current node needs to be current node dot next. Is it true? Or new node dot next? New node dot next. So if we do current node dot next, then since we have our current node as here, it will just move over to the one dash. But to say current node equals to new node, which is going to be one prime, and then dot next is going to be 2. So this is how we're going to create a deep copy. And so we have created this chain so far. Next, we need to also assign the random pointer as well in our newly created node. Okay, this is what we need to do. And how are we going to do it? So if you think about this, right, this is fairly simple actually. So if 1 points to 3, so we already have it written. Let's just take it out. If 1 points to 3 and 3 points to, so if 1 points to 3, basically if 1 points to 3, then we need to have 1 dash points to 3 dash.